Hello ma'am, I am Mohammad Riazuddin from Institute of Aeronautical Engineering, bearing roll number 20955A0408 from ECE B section. Today's my topic is inconsistency of Ampere's law for time varying fields. Before going to the topic, first we will see what is the Ampere's law. Coming to the Ampere's law definition states that the line integral of a magnetic field intensity along a closed path is equal to the current distribution passing through that loop. Coming to the Ampere circuit's law, we know that the line integral of tangential component of H around the any closed path is equal to current enclosed by the path. Here H is the tangent of the closed path. Here H is equal to the current enclosed by the path. It can be represented mathematically as closed loop of line integral of H into dl is equal to current enclosed by the path I enclosed. The units are A by M, nothing but ampere per meter. dl as a meter, will get amperes. By applying Stokes theorem to the line integral of, then it becomes integral of L becomes double integral, then it is nothing but integral of S, as here closed surface of line integral of H into dl is equal to surface integral of del cross H. Here H is taking curl of H, so del cross H into ds. Then the current can be given as surface integral of J into ds is equal to I enclosed. This is nothing but third Maxwell equation in integral form, and if you take the del cross H is equal to J, the del cross H is equal to J is nothing but the differential form or point form for static magnetic field, and take divergence on both sides of del cross H and J or third Maxwell's equation, then it becomes del cross H equal to del dot J is nothing but is the divergence of curl. This divergence of curl, it becomes, as we know from vector calculus, the divergence of curl of any vector field is given as 0. That is nothing but 0 is equal to del dot J. From this we can know that here 0 equal to del dot J, but from the continuity equation for time varying fields, del dot J is equal to minus dou into rho v by dou t, which is not equal to 0. So from this we are saying that inconsistency of Ampere circuit law. This is nothing but inconsistency. It means the del cross H equal to J is fails for time varying fields. So now coming to the modification of equation for time varying fields, as del cross H is equal to J plus JD by adding the constant term as JD to the previous equation, and again apply the divergence. Again apply the divergence on both sides, then we'll get del cross H equal to del dot J plus del dot JD, which is nothing but from vector calculus. Again we know that del cross H is equal to 0, but coming to this minus rho dv by minus dou rho v by dou t plus del dot JD, which is equal to del dot JD is as a constant term. We can write it as dou rho v by dou t, where del jd is equal to dou by dou t of del d rho v by t. Rho v is nothing but d del d. As we are writing like this, then it becomes del as a constant, del into dou by dou t of d, which can be called as jd is equal to dou by dou t, dou d by dou t, which is known as displacement current density. And del cross h is equal to j plus dou d by dou t. It can be called as modified Ampere circuit's law for time varying fields. Here jd can written as dou d by dou t. So here the equation, this j plus jd is nothing but j plus dou d by dou t, where from the equation J can called as conduction current density and JD can called as JD is nothing but dou d by dou t, which is nothing but displacement current density. This displacement current ID can given as surface integral of JD into ds. This JD is nothing but dou d by dou t into ds. By this we can modified uh, modified for the time varying fields. Thank you.
Thank you.